Hi everybody, here's a video on polar curves. In class, you saw the main types of polar curves on the graphing calculator, the limacon, cardioid, lemniscate, rose curve, spiral of Archimedes, and the circle. This video, my goal is to get you comfortable with the actual polar plane, which you haven't seen yet. You were just messing around with the graphing calculators. So we're going to plot points, we're going to figure out how to get polar coordinates and convert from polar to rectangular and back. So in polar coordinates, they are very different from rectangular coordinates because instead of using x, y, going left, right, up, and down, we go in a circle. So we're going to label a point P with coordinates r, theta. So r is going to be the distance from the pole right here, or what you're used to calling the origin. So here would be r equals 1, here would be r equals 2, and so on. So it's circles with larger and larger radiuses going out from the center. And theta is going to be the angle rotated from the positive x-axis. So anytime you're on the unit circle and you're going theta degrees around, you always start at the positive x-axis. That's the standard spot to start. So the polar plane, again, has circles of radius 1, 2, 3, 4 going on. These are the unit circle values going around. So your unit circle values that you've seen are the same as always, and those you need to know because they're usually not labeled for you. Keep in mind that if we're plotting in rectangular plane, there's going to be one address for one point. So if I plot this point right here, that's negative 2, 1, and it's never going to be anything except negative 2, 1. If you're in the polar plane, a single point, no matter where you plot it, let's say it's there, you can have multiple addresses. You actually have infinitely many addresses because you can keep spinning around, and every time you spin an extra revolution, it's another 2 pi added on to theta. So keep that in mind. So let's just start plotting a couple points here. Again, these are all in the form r theta. So if I want to plot 3 comma pi over 3, you start at the center, you move out 3 radiuses to here, and then on this circle of radius 3, you just rotate pi over 3. And you're right there. So I'll call that 1 right here. So let's call this one 2. If I want to do 4 comma pi over 6, 1, 2, 3, 4, rotate, here's pi over 2, and right there. 5 pi over 6. It's almost 6 pi over 6, which would be here. If I'm going to do 1 comma 4 pi over 3, I only go up to 1. There's pi over 3. 2 pi over 3 here, 3 pi over 3, 4 pi over 3, right there. So these 3 points, they're not that bad to plot. They were all positive values of r and theta. Now you can have negative r values. So let's say we have negative r theta and r theta. They're going to be reflections through the pole. So let's put some actual values here to make this easier to visualize. Let's do 3 comma pi over 4. Which would be 1, 2, 3, and pi over 4 is the one in the middle always. So here's 3 pi over 4. Now if I want to plot negative r theta, negative 3 pi over 4, that would be, instead of going to the right, remember we're on the x-axis, you start at the pole and go left. And from this spot here, you rotate pi over 4. Now you might be wondering, why didn't you rotate this way? When you rotate, you always go counterclockwise, always. So whether you start on the positive x-axis or negative x-axis, you always go counterclockwise, negative 3 pi over 4. And notice these 2 points are reflected over the pole right here. And they are actually a distance of pi apart, half a circle. So you can say this rule here, write this down. Negative r theta is equal to the positive version of it plus pi. So here's the positive version. If you add pi, you get the negative version. All right? So let's try finding 3 different addresses for each ordered pair here that we plotted above. So I'll do one of them with you, and then I'll have you try them. So where am I here? This was 3 comma pi over 3. This is point number 1. Another thing that I could do is I could go out 3, and instead of rotating pi over 3, I could rotate an extra circle here, and that would be 2 pi plus pi over 3. That would be 7 pi over 3. Like that. That's one option. Now I want one with a negative r value, so let's try doing -3. So let's go 1, 2, 3, and then I would rotate this way. So starting from here, that would be pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. So that's another option. And then let's get a third point. So this time, instead of doing an extra revolution, let's do 2 extra revolutions. So I would go out to 3. Here's pi over 3. Add another revolution, and then add another revolution. So that would be adding not just 2 pi, but adding 4 pi. So that'll be 13 pi over 3. So go ahead and get 3 more addresses for these two here. Make sure one of them has a negative r value, and make sure you're rotating counterclockwise here. So pause the video and go ahead and do that. Alright, so let's talk about the equations you're going to need for polar and rectangular conversions. I'm going to show you how you can get them so that they'll be easier to memorize or remember, so that we don't necessarily have to memorize something brand new. It's basically things you already know. Let's say I have a point here, I'll call it point P in the rectangular plane, and it has ordered pairs x, y. And let's say that it is theta degrees from the x-axis. So I want to find values of x and y. Now if I wanted to find the actual lengths of x and y, and let's say I knew the length of r and I knew the length of theta, so I'll put a check here. So you know r and you know theta, but you wanted x. Let's do x first. You could use your SOHCAHTOA trig identities to find them. So if I wanted to do x, I could use the trig relation that relates x and r. That would be cosine. So I would say cosine of theta is adjacent over hypotenuse, x over r. And if you wanted just x, you would do r times cosine theta. So that's one of the conversion equations you need. Now if you wanted to find the y, you would use a trig formula that relates the opposite to the hypotenuse. That would be sine. So sine of theta would be y over r. So then you would just say y equals r times cosine theta. So those are the 2 equations you'll use to go from polar to rectangular. Now let's say you wanted to find the length of r, and for this situation, let's say we know x and y. Well, if you know x and y, let's say you know x and y, but you want to know r, then you could just use a form of the Pythagorean identity, where instead of a squared plus b squared equals c squared, you could say x squared plus y squared equals r squared. And then just to get r, you would do the square root. That's another formula that you'll use. And if I want a formula that relates x, y, and theta, you want to think, okay, what trig formula relates the opposite and the adjacent? Well, that would be tangent. Tangent of theta is y over x. And if you wanted to solve for theta, you would do tangent inverse of each side. And you would get that. So that's what you're going to actually use to convert. If you can remember those 4, you've done all these things before. It's just a matter of knowing when to use them now. That's how you're going to convert. Alright, here is converting from polar to rectangular. And here's converting from rectangular to polar. So put a big box around these because these are the formulas that you don't want to get lost in your notes. You're going to use them a lot. So pause and write those down. So let's go from from polar to rectangular. These are a little bit easier than the other way because when you go this way, you don't have to think about this situation here. This is similar to what we were talking about, how you can have a negative r value, but you would have to add theta to your angle. So if you have a negative x value, you have to add theta to your angle. Alright, so let's convert from polar to rectangular, and this is one of the first point that we plotted up here, 3 pi over 3. I'll have you do the other 2. So if I'm going to convert, then all you have to use is these 2 formulas here. And you just take your r and you multiply by the cosine of pi over 3. To get the x, to get the y, you take your r, you multiply by the sine of pi over 3. And if I'm going to keep it in unit circle values, then cosine of pi over 3 is a half. So that'd be 3 halves. And here this would be 3 times root 3 over 2. So 3 root 3 over 2. So your rectangular coordinates x, y would be 3 over 2 and 3 root 3 over 2. Now to show you that these actually are the same, I'm going to go to decimals because it's easier to see that they really are the same thing. This is, if you get a calculator, 2.598. So let's go up to our graph here and see what would happen if we were going to actually just plot the point 1.5 and about 2.6. So if you go here, here is our point 3, pi over 3. We converted it to rectangular. Picture going over 1 and then 1.5. Your x would be right there. And if you look up, this point does have an x value of 1.5. Picture the circles being gone. We're just on tick marks now. And then going up 1, 2, 2.6 would be about there. It does have that y value. So you can see that they are the same thing whenever you convert them. So I want you to do these two right here. 4, 5 pi over 6, and 1, 4 pi over 3. For these two, when you convert them, I want you to get the unit circle values, just like we did right here. And then I also want you to get the decimal values, like I did here, because I want you to go to your graph and picture plotting it in rectangular coordinates and see if the values actually match up. That's the best way to see if you did it right. So now we're going to try converting to polar coordinates given rectangular coordinates. Alright, so for the first example, converting from rectangular to polar coordinates, I'm going to do 3, 2. So if you visualize 3, 2 on the rectangular plane, it's going to be right here. I'm going to go ahead and plot it on a polar plane as if it were rectangular here, just so we can compare the two. So I would go over 3 and up 2. I'd be right in the middle there. So if I'm going to find r, then that's the square root of my x squared plus my y squared. So that'd be 3 squared plus 2 squared. That'd be the square root of 13. I'm going to go to decimals just so when I compare them, I can see it easier. That's about 3.6. Now, my theta is tan inverse of y over x, so that'd be tan inverse of 2 over 3. That would be about equal to 0.588. Now, this is radians. It might be weird for you to picture what about 0.6 radians looks like because you're used to like the pi values of radians. But remember, from here to here is pi radians. Pi radians is 3.14-ish. So if this is 3.14 radians, that'd be like 3. This would be like 1, and this would be like 2 radians. So 1 radian, 2 radian, 3 radian, pi radian. So about 0.6 radians would be like right about there. So if I'm going to plot, therefore this has r theta equal to 3.6.588. Picture going over 3.6. Notice your r has to be bigger than your x because I have to go out a little bit more than 3 to 3.6 so that when I rotate, I end up where I want to be. So anyway, or I'm sorry, whenever I go around, I end up where I want to be. So 3.6 is about here, and then rotate not quite 1 radian. It'll work out. You'll be in the same spot. Because I was in quadrant 1, I didn't have to worry about adding pi or anything. Now let's do one that's not in quadrant 1 and think about how we're going to adjust our pi value to get where we want to be. So negative 1, 1 is in the second quadrant here, and I'm going to plot it negative 1. There's 1, be like right there. So here's negative 1, 1. And to get my r value, let's do x squared plus y squared. That'd be the square root of 2, which is about equal to 1.414. You probably recognize that decimal, but as square root of 2. Tangent inverse is y over x. Tangent inverse of negative 1. So let's think about our unit circle here. Tangent is negative here and here, because here tangent's positive, here all are positive. Negative 1, tangent's only negative 1 at the middle one, which is some form of pi over 4. So I could either go like this, like this, like this, or like this. Any of those work. So we have to pick the one that's going to work. Now, you don't want to pick this one, which would be negative pi over 4, or this one, which is 7 pi over 4. Because that would put me in quadrant 4, and I need to be in quadrant 2. So if you want to use the formula way up here, which had us adding pi to something, if x is negative, x is definitely negative here, then you could take your negative pi over 4, which we don't want, and add pi to it, which would then give us 3 pi over 4. Which is this guy. So we want to use a 3 pi over 4 version. And that makes sense because it's in quadrant 2 and I'm in quadrant 2. So I'm going to use the 3 pi over 4 version. Now you could do variations of it. Remember,